This presentation is entitled Measuring Air Pollution in Railway Stations. It's a presentation I gave for the University of Birmingham College of Engineering and Physical Sciences Lockdone series in July 2020, but it actually describes some work that was carried out 2 or 3 years before that. Although I'm giving the presentation, the results that are included owe a great deal to my co-workers, and in particular Professor John Thorns of the School of Geography and Dr. Alice Hickman, formerly of the University of Birmingham in my department in the School of Engineering, but now working for Network Rail. So an introduction. Birmingham New Street is one of the busiest stations outside London, up to 200,000 passenger movements per day. It was upgraded in 2015 with a major upgrade in the ventilation system. In going through Birmingham New Street, we have a lot of diesel trains, 45% of the total, up to 600 diesel train movements a day. And those of you who know New Street will know that the 12 platforms lie underneath the concourse in a tunnel-like environment which traps diesel air pollution. And certainly before 2015, it was quite notorious for the awful air quality that would be experienced there, particularly late in the evening when trains were coming there and being put to bed. In 2016, 2017, the University of Birmingham began to work in collaboration with Network Rail to develop an extensive monitoring campaign to try to better understand the air quality in and around the station. Partly this was driven by regulatory issues. Although air quality in closed railway stations has been largely ignored up to the present, and indeed the legal requirements are really rather obscure. Nonetheless, diesel exhaust is now widely recognised as a carcinogenic pollutant and results in increased mortality from lung cancer, amongst other things. In total, diesel engine exhaust emissions contain a lot of pollutants, the oxides of nitrogen, which of course result in respiratory issues, particulate matters, similarly, that can penetrate deep into the lungs and aggravate heart and lung diseases, carbon dioxide, which can cause headaches, dizziness, confusion, loss of consciousness, and so on, and carbon monoxide, which effectively saturates the bloodstream and prevents it from taking up any more oxygen. In addition, there are oxides of sulfur, the PAHs, the polycyclic aromatic hydrocarbons, both of which are fairly unpleasant, and the carcinogenic volatile organic compounds. The EU regulatory limits on ambient levels, these are public health limits, so apply to people going about their daily business. And there are some numbers here that I'll return to later in the talk. The hourly average of nitrogen dioxide shouldn't exceed 200 micrograms per meter cubed, more than 18 times in 1 year. The annual average shouldn't exceed 40 micrograms per meter cubed. Particulate matter of less than 10 microns, PM10, should have a daily average of 50 micrograms per meter cubed that shouldn't be exceeded more than 35 times in any 1 year. Its annual average should be 40, and the annual average of PM2.5 should be 25 micrograms per meter cubed and not above. As I say, I'll come to those figures in a moment. There's more recent legislation for occupational limits, workplace exposure limits. For nitrogen dioxide, an 8-hour limit shouldn't exceed 950 micrograms per meter cubed. 15-minute values shouldn't exceed 1,910, and nitric oxide 8-hour values shouldn't exceed 2,500 micrograms per meter cubed. But let's think about Birmingham New Street itself. It was built in 1854, one of the first large stations on the network at the end of the line from London. Then it was a large canopy station, very unlike what we know now. It was effectively enlarged over the course of the 19th century by the adjacent Midland Railway Station. So in effect, it became two railway stations next to each other, each with their large canopies. In 1966, the canopy structure was replaced by a brutalist construction that people grew, frankly, to loathe over the decades. It was designed for a relatively small number of passengers and became very crowded and very unpleasant till its ultimate demise in 2014. As I say, it was notorious for poor air quality. In 2015, there was a major redevelopment of the station, and that has resulted in a modern station with a large concourse, much better advert for the city of Birmingham than the old Birmingham New Street. The platforms are to some extent the same, though. They have been upgraded, but they're still beneath ground level. There's still the possibility of poor air quality due to emissions remaining in the station. To measure these, 98 fans were installed across the platforms, bidirectional fans that could blow out pollutants through either end of the station, and an array of carbon dioxide sensors that control the fan speeds. Note that carbon dioxide is used as a surrogate for all the other pollutants, and we'll come back to that in a few moments. When the tests were carried out, the services through New Street were operated by a number of companies: the West Midlands Railway, London North Western Railway, Virgin Trains, Transport for Wales, and Cross Country. Virgin now has been replaced by Avanti with very much the same rolling stock. Throughout this talk, I will refer to Virgin as the train operator because that's what it was when the tests were carried out. The Birmingham New Street stands at the centre of the services for all these operating companies. For West Midlands Railway and London North Western Railway, it obviously stands at the centre of the local services and the long distance services to London and to Liverpool. For Virgin Trains, it's part of their intercity network. For Transport for Wales, it's actually quite an important station for them, as a number of their services coincide there. For cross-country trains, which we'll see are particularly important, it's effectively the centre of their cross-country hub. So it's an important station for all these different operating companies. This next slide shows a screenshot from real-time trains showing an hour in the life of Birmingham New Street. And you can see the number of trains that pass through it. A huge number of trains go through the station in any 1 hour. And this is actually what makes Birmingham New Street so prone to disruption, because a small disruption to one service can have knock-on disruptions to a lot of other services. There are both electric trains and diesel trains through the station. The electric trains include the Class 390 Pendolino, the Class 350 Desiro trains, and the Class 323 commuter trains. Note that the newest of those was built in 2004. The diesel trains included, I should say, the Class 43 HSTs, which no longer work through the station, that date back to 1975. Sprinter trains of various descriptions and Turbostar trains as well. The dates of all of these trains are quite important because they were built before the more stringent emission regulations came into play, and therefore their engines do not perform as well in terms of pollutant as modern engines do. A particularly important diesel train from the point of view of Birmingham New Street is the Class 220, 221 Voyager, operated by both Cross Country and Virgin. A 4 or 5 coach unit that sometimes travels in a double unit formation. We'll see this train is particularly significant in a few moments. If we look at just a brief period here of half an hour now. And what I've done there is simply to highlight the diesel trains that operate in that half hour. And you can see that roughly half the trains are diesel trains. So to the experiments then. We carried out a number of experiments of different types and different sensitivities. We used the technique known as diffusion tubes, small sampling instruments that could be very cheaply placed at a large number of locations around the station. And these measure weekly, 2-weekly averages of nitrogen dioxide. So these give us a clue as to what the pollutant is doing across the station. And we also put diffusion tubes in the lounges, the yellow, blue and red lounge, above the platforms, and indeed in the streets around New Street, with cooperation, very good cooperation from Birmingham City Council, for which we're very grateful. The main experiments were carried out on platforms 10 and 11, where we put 3 measuring sites, A, B and C, along the platform, and you can see a picture of the instrumentation cupboard there. And these measured nitrogen dioxide, particulate matter, carbon dioxide, and also black carbon. We also made wind measurements at the end of each platform. There was also a set of mobile instrumentation that we took around platform by platform during the course of the experiments. Now, to remind you, first of all, of these regulatory limits, as I said I would. The important figures here for nitrogen dioxide, the hourly average of 200 and the annual average of 40 micrograms per meter cubed. If we look at the diffusion tube results, which give long-term averages of nitrogen dioxide, we can see they give very high values. For instance, for platform 2, the values are well above the 200 values by a factor of 2 or more into places. But not only on the platforms, we're also measuring some very high values in the lounges, which suggests a considerable leakage of the pollutants up the stairs into the lounge area. And outside, well, that shows in platforms 8, 9, 10, 11 and 12, a series of very high values indeed as well. In the area outside the station, we were measuring much lower values, which you might find paradoxical. So in fact, at the time we made the measurements, if you wanted to get clean air, it was best simply to leave the station. Platform point K, we were down at really very low levels, well below even the average annual level. Now let's look at some shorter term measurements, and here again the figures of 240 are important, but also the PM10 values of 50 and 40 for PM10 and 25 for PM2.5. Now what we show there are time series over the measurement period from the 17th of November 2016 to the end of January 2017 for NO2, PM2.5 and PM10. And we show the data from each of the 3 measuring sites there. Just concentrate on the data from site C, the black line, the site in the center of the platforms. These are daily average values. If we first look at nitrogen dioxide, we can see the values in general are much higher than the 250 figures that I've quoted. The average over the period of 307. Interestingly, if we look at that highlighted period, that's Christmas 2016, when the number of trains going through the station fell to 0, and so did the pollutant levels. There's a similar low point in January, 12th of January 2017, when there was a very strong wind, which blew all the pollutants out of the station. And the correspondingly high set of values right at the end of our experiments, which was due to an anticyclone with almost no wind sitting across the station. PM 2.5 values, average of 32 as against 25, so not too bad. PM 10, average of 43 as against 40 and 50, so again, still exceeding the limits, but not as bad as NO2. If we come on to an even shorter term averages and just look at a day's worth of data here, again, all of these figures are for nitrogen dioxide. And so they're measured at platforms 10 and 11. And what we do is mark the number of trains of different sorts in the station when we're making those measurements in the platforms. And perhaps the interesting thing is it's rather difficult to see any correlation between number of trains and peak levels, except perhaps for some trains very early in the morning. And what seems to happen in New Street is that fundamentally the pollutants are mixed up quite quickly. So while you can pick out high levels of pollutant when the trains start arriving in the station at a localized point, this pollutant spreads very rapidly. But note the values, these very short-term values of 10,000, almost 15,000 in places. Very, very much higher than any of the limits. We are able to look at this effect of trains in a little more detail by calculating the ratio of the concentration when the platforms are occupied by specific trains to the average concentration. And we can see that when diesel trains are in platforms 10 and 11, generally the average was above the average for all the period. This is particularly true for when the class 220, 221 diesels are in the platform. When they're both in platforms 10 and 11, the pollutant concentrations are twice as high as the average value, which again says something about the Voyager trains. You remember I said that the fans used carbon dioxide as a surrogate to actually predict the other pollutants with a view to turning the fans on and off. What we were able to do for a couple of days was to find the correlation coefficient between CO2 and the other pollutants. And you can see the correlation coefficients are really quite low. So it's not altogether the best way of predicting what the other pollutants will be to use carbon dioxide as the surrogate. If we look at the workplace exposure limits, which we calculated sometime after the experiments, we can again see that these limits are quite seriously exceeded for both the 15-minute value, that's the blue values, and the 8-hour values, that's the green values. And the same for nitric oxide 8-hour value. There is another measure of air quality called the Daily Air Quality Index, which combines a number of parameters and gives a score of 1 to 10. And we are able to make a direct comparison of the Daily Air Quality Index in Birmingham New Street with the values measured on the A4540 and on Moor Street. And you can see there that the values are basically, they reach the maximum value of 10 every day except Christmas Day and Boxing Day. And they're very much higher than the values of 1 and 2 on these busy main roads through the centre of Birmingham. On the basis of this, Network Rail naturally adopted some sort of intervention plan. And that included methods to reduce train idling in the station, to enforce auto shutdown of engines after a certain amount of time, to work around practices of train coupling and decoupling, to carry out occupational health checks for their staff. It also resulted in engagement with a lot of external authorities, with the Department for Transport, with the Office of Rail Regulator, Railway Safety and Standards Board, as well as with Network Rail. and best practice groups were set up. A steering group was set up to perform research at King's Cross and Edinburgh. DFT used these results to think about how they might award train operator franchises in the future, which of course has been somewhat superseded by the current situation with COVID-19. And also it was used in justifying fan enhancements and as one of the justifications for electric battery hydrogen trains. It was the first of a series of projects that made the railway realise the importance of air quality that's driving all sorts of improvements in the passenger and the freight sector at the moment. As I mentioned, there was a comparison study funded by RSSB, not carried out by the university, at King's Cross and Edinburgh stations. And you can see King's Cross is a canopied terminal station, very spacious. Waverley is a through station with canopies over as well. And the comparison that we see here, which was carried out before the University of Birmingham had looked at the workplace exposure limits, we can see NO2 on the left, PM2.5 on the right. We see under each column an EU ambient set of values compared with the EU ambient limit, and similarly a workplace exposure limit column for both NO2 and PM2.5. For NO2, all three stations were exceeding the public health limits, the EU ambient limit values of 40 micrograms per meter cubed, the annual average values. None of the stations were, well, rather neither King's Cross nor Edinburgh were exceeding the workplace exposure limits, although of course Birmingham New Street did. The situation for the particulate matter is rather better, only Birmingham showing exceedances there, but nonetheless still perhaps higher than one would wish it to be. So what is the future? Well, the future is partly new trains. All of the train operating companies almost are receiving new trains. West Midlands trains, class 196 and class 730. Transport for Wales, class 196. Virgin trains, now run by Avanti, as part of the West Coast Partnership, again will receive new trains produced by Hitachi. And the odd man out is Cross Country, who is still running the cross country trains. And there's been a delay in the awarding of any new franchise that will specify what trains are required. And indeed, the whole system is likely to change when the dust settles after the current pandemic. So the conclusions then. The air quality in Birmingham New Street Station was probably as poor as anywhere in the UK. It's much, much better now following the intervention by Network Rail. But I think everyone would see that as only a short-term solution. And to reduce levels of long-term acceptable values, both in New Street and across the railway system, requires complete electrification of the system. The lessons learned at Birmingham New Street were extremely valuable and are being applied to other enclosed railway stations by the Office of the Rail Regulator. And there's ongoing work at Birmingham New Street, at other stations, and indeed on trains to measure concentration levels and to try to find any hotspots and try therefore to alleviate the issues. Thank you for listening, ladies and gentlemen. I hope you enjoyed the presentation. Thank you.